Okay, so we'll see the next problem. Okay, so here the question is again to find the reaction forces at all contact surface. To find the reaction forces at all contact surface, the given data is this is ball 1, this is ball 2, so ball 1, ball 2. Okay, so radius of ball 1 is 350 millimeters and radius of ball 2 is 250 millimeters. It is radius is given, and weight of ball 1 is 600 newtons and weight of ball 2 is 500 newtons. Okay, so first we need to mark the reaction contact surfaces. So you can see here, we'll call this as contact surface. I will call this as A. Okay, I will call this contact surface as B. I will call this contact surface as C, right? And I will call this contact surface as D. You can see here there are totally one here, this between these two, one here, one and here one. So 1, 2, 3, 4. Totally there are 4 contact surfaces. Totally there are 4 contact surfaces. Okay, so now let's draw the free body diagram. Okay, so now this is for this is a lower ball, or you can say the bigger ball. Okay, and let this be the upper ball. Can you see this? Okay, now let it be your x-axis, let it be your y-axis here. Again, let it be your x-axis here, let it be your y-axis here. Now at every contact surface there exists a normal reaction which is perpendicular to the contact surface. So see here at A. So at A there is a perfectly vertical contact surface, that means perfectly horizontal normal reaction, that is it will be acting like this. It is 90 degree here. Okay, so it will be acting like this. I will mark this as RA. I will mark this as RA, right? And see here, you can see C, it is also perfectly vertical, that means perfectly horizontal normal reaction. So I will call this as RC. See here at D, it is perfectly horizontal contact surface, that means perfectly vertical normal reaction which is perpendicular to it. So this is RD, right? RD, right? Now other than these forces, what are the forces acting? First we know that weight will be acting vertically downwards. So I am marking here, you can see the weight is acting vertically downwards. So this is W2, right? And here W1 is acting vertically downwards. So RD is acting like this, RD is acting like this, and W is acting in the downward direction. Okay, so now we got RA, RC and RD. You can see here RB. Now RB is acting, it is not perfectly vertical, it is not perfectly horizontal, it is acting at some angle. We don't know that angle. So how to find that angle? For that, what I am doing here, please see here carefully. So let us join these two centers. Can you see this? Let us join these two centers. That is radius of, now this total distance is equal to how much? Radius of this ball plus radius of this ball, right? Radius of this ball plus radius of this ball is this. Now from this point I will draw a perpendicular, right? So this perpendicular I will join this. Okay, so first join these two. From this erect a perpendicular to this erected perpendicular, join this. Okay, now this is a triangle. Now this is theta. Now this is theta. Let us say that as small a, small b, small c, triangle small ABC. I am drawing here small ABC. 1 second. Yeah, you can see here. Small a, small b, small c. Right. Now what is AB? AB is radius of ball 1 plus radius of ball 2. Right. So that is 350 plus 250. That is 600. Right. Now what is AC? What is AC? You can see here AC can be obtained as total is 1000. So 1000 minus of radius of ball 1 minus this. What is this? This is nothing but this. That is radius of ball 2. That is 1000 minus R1 minus R2 is your AC. From here totally it is from here to here is 1000. From here to here it is 1000 minus this. This is what? Radius of ball 1 minus this. What is this? This is parallel to this. What is this? This is R2. So 1000 minus R1 minus R2 is your AC. So that is I am writing here 1000 minus R1 minus R2. Right? So that's equal to how much? 1000 minus 600, that is equal to 400. If this is your theta, then cos theta is equal to how much? Cos theta is equal to adjacent by hypotenuse. So that is 400 divided by 600. That means theta is equal to cos inverse 400 by 600. So theta is equal to cos inverse 4 divided by 6. The answer is 48.18, or you can say 48.2 degrees. So 48.2 degrees. That means now this reaction force RB is acting at an angle 48.2 degrees with respect to horizontal. Okay, now you can see here, first we'll consider this ball A. So now RA is acting like this, because that means we are drawing here reaction forces. This ball puts some action on this ball and gets the reaction back. That's why we are drawing reaction forces. Similarly here, this ball tried to push or try to put action on this ball and gets the reaction back. I am drawing the reaction force here. Similarly for this, now for RB, I am for ball A. Okay, now this ball tried to push this ball downwards and gets the same back. Action and reaction are equal and opposite. So for this, the reaction is acting like this. For this, the reaction is acting like this. Remember here, we are drawing reaction forces. So this is the direction of RB. This is your RB. What is the angle here is theta. The angle here is theta. Theta is equal to 48.2. When you consider ball, the upper ball, okay, now this ball tried to push this ball upwards and gets the reaction back. So we are drawing the reaction force here. So this is the direction of RB for this ball. This is the angle theta with respect to horizontal. This is the direction of RB. Okay, once you draw this figure, then the remaining problem is very easy for you. Okay, so the upper ball, the lower ball, okay, weight will be acting vertical downwards for both the balls, that is right. So for every contact surface, there is a normal reaction which is acting perpendicular to the contact surface. So this is here, here, here. So RA, RC, RD. Now RB is acting at some angle with respect to horizontal. With respect to horizontal. What is that angle? We don't know. So first, to find the angle, I am drawing these two. I am drawing a perpendicular from here and I am joining this. I am taking ABC triangle here. So ABC. So AB is RA plus RB or R1 plus R2, and AC is totally 1000 minus R1 minus R2. So you got theta 48.2. That means for RB is acting at an angle 48.2 with respect to horizontal. With respect to horizontal. Okay. So now when you consider this ball tried to push this ball downwards and gets the reaction back. So I am drawing the reaction force here. When you consider this ball tried to push this ball upwards and gets the reaction back. I am drawing the reaction force here. Okay. So this part is very much important. After that, remaining part is very easy. Okay. So this is a free body diagram. Then we'll draw the coordinate system now. Okay. Now see here, I am drawing the coordinate system for the ball 2, or you can say the upper ball. That is for this ball. Now you can see here for this ball, or you can say ball number 2. Okay. Okay. So let us consider the upper ball first. So I'm drawing the coordinate system here. Okay. So first ball 2. Let's say the coordinate system of ball number 2. Okay. So let it be your x-axis. Let it be your y-axis. Okay, now you can see here RA is acting like this. That means RA is passing through positive x-axis but actually acting in negative x-axis. So this is actually the direction of RA. Right, now weight will be acting vertically downwards, so that will be W2. W2 is equal to 500. It is given in the question. Okay, next RB, you can see here where RB is acting. Actually RB is acting, it is passing through the third quadrant but actually acting in the first quadrant. So at an angle theta with respect to horizontal. So let it be RB, angle is theta, theta is 48.2. So you can see here 1, 2, 3. As there are only 3 forces, we can apply Lamin's theorem. Okay, so we can apply Lamin's theorem, or we can use equations of equilibrium like summation fx equal to 0, summation fy equal to 0. Now I am going to use here Lamin's theorem. So according to Lamin's theorem, so first we'll consider 500 divided by sine of the angle between other 2 forces. So from here to here, that is from negative x-axis to positive x-axis, the angle is 180. I want only this angle. I want only this angle. That is 180 minus 48.2. So 500 divided by sine 180 minus 48.2. So 180 minus 48.2 is 131.8. So sine 131.8 is equal to, I will consider RA force now, RA divided by angle between other two forces. Now other two forces are RB and W2. That means I want this angle. One second, let me show here. Now I want this angle, right? So that is equal to from this negative y axis to positive x axis, angle is 90. That is from here to here, this is 90. 90 plus 48.2 is 138.2. So sine 138.2, that is equal to RB divided by angle between other two forces, that is RA and W2. So you can clearly see here it is 90. So sine 90. So you can see here 131.8 plus 138.2 plus 90 is 360. So this is correct, right? Now RA is equal to RB is equal to, okay, so RA is equal to 500 into sine 138.2 divided by sine 131.8. It comes out to be 447 newtons, and RB is equal to 500 into sine 90 by sine 131.8. So it is 670.71, 670.7 newtons. This is your RA, this is your RB. Okay. Now we have considered the upper ball. We found the reactions, that is reaction forces, that is at point A, at point B. Now we'll consider the lower ball. Okay. Now we'll consider this lower ball. You can see here lower ball, and we'll consider the coordinate system. Now I'm drawing the ball. You can see here. One second. Yeah, it is ball number 1. Ball number 1. Okay. So again, let it be your x-axis. Let it be your y-axis. Okay. Now weight is acting vertical downwards. So weight is acting vertical downwards. Weight of ball 1 is given as how much? You can see here it is 600. So it is 600 newtons. It is W1. Okay. Now you can see here RC is actually is passing through the negative x-axis, but actually acting in the positive x-axis. So this is the direction of RC. So I will call here RC. Okay. Now RD is acting vertically upwards. You can see here RD is acting vertically upwards. So this is the direction of RD. Now you can see here RB is acting passing through the first quadrant, but actually acting in the third quadrant. So this is the direction of RB. What is the angle? Theta with respect to horizontal. So theta with respect to horizontal, theta is 48.2. 48.2. So there are only 1, 2, 3 and 4 forces. Okay. So this is the direction now. Now you can see here 1, 2, 3 and 4. There are totally 4 forces. So we can't apply Lamin's theorem here, because the limitation of Lamin's theorem is we can apply Lamin's theorem only when the number of forces is equal to 3, and we can't apply Lamin's theorem when we don't know both the direction as well as the magnitude of the force. Now now we can see here the number of forces 1, 2, 3. Totally the number of forces is equal to 4. So we can't apply Lamin's theorem. We have to use equations of equilibrium, that is summation fx equal to 0, summation of y equal to 0. So first condition, summation fx equal to 0, or you can say summation of horizontal forces, summation h equal to 0. Summation fx equal to 0 means what? We need to consider only x component of all the forces. Now RC is acting purely along x-axis, so acting in positive x-axis, so plus RC. You can see here plus RC. Next, consider RD. It is acting purely along y-axis. There is no x component, so its x component is 0. Next, we'll consider RB. RB acting in the third quadrant. In third quadrant, x component is negative. So first we'll put negative sign. Now we need to write the component. So to write the component, we need to follow the rule: where there is a theta, there is a cos. Simple. Now theta with respect to x-axis, so x component is cos. So RB cos theta. Theta is 48.2. Now again consider 600. It is acting purely along y-axis. There is no x component, so is equal to 0. RC minus RB cos 48.2 is equal to 0. So RB is equal to, we know the value, 670.7. So from this equation, RC is equal to 670.7 cos 48.2. 670.7 into cos 48.2. The answer is 447. RC is equal to 447 newtons. Okay. The second condition, summation Fy equal to 0. So consider, if summation Fy equal to 0 means we need to consider only the y components. So RC acting purely along x-axis, there is no y component. Consider RD acting along purely along y-axis, positive y-axis, that means plus RD. Okay, now RB acting in the third quadrant, its y component is negative. First we put negative sign, then you write the component. So to write the component, theta is with respect to x-axis, that means x is cos, y is sine. So it is RB sine 48.2 and minus 600 is equal to 0. So from this equation, RD is equal to 600 plus RB sine 48.2, RB is 670. So it is 600 plus 670.7 sine 48.2. The answer is 1099. 1099.9, or you can say 1100 newtons. Okay, so RA, RB, RC and RD. So we have found all the reaction forces at contact surfaces RA, RB, RC and RD. Okay, this completes the problem.